those of you watching at home, there are 3 note cards that you need to have. This one needs to be labeled families of functions. This one needs to be labeled quadratic functions. And this one needs to be labeled transformations. So put those in your flip charts and your note cards for later reference. So today what we're going to learn how to do is how to take a function and find what each piece of it does. What does it do? So look at this. You have this written down. Keep it close for the whole lesson. You'll need to refer back to it. First thing we have is f of bx plus c. The inside piece of that. Well, we know, remember from the vertex, that inside piece affects the left and right movement of the function, right? Like on an absolute value function, absolute value x plus 3 moves left 3. Do y'all know what I'm talking about? Yes. Okay. So that moves left. Now, the b does affect the movement also. So the left and right movement is c divided by b. Most of the functions you saw in absolute values, the b value was 1, so it's just c. So we'll have to look at something that have both. The left and right movement works opposite of what you would think. If c over b is positive, you move left. If c over b is negative, you move right. Do y'all remember noticing that with vertexes, how the inside was opposite? Remember that? So same thoughts. Adding on the outside, add, moves it up. Subtracting on the outside moves it down. A negative on the outside of a function is a reflection across the x-axis. A negative on the inside of the function is a reflection across the y-axis. And then a number multiplied on the outside of the function, you may remember with absolute values, that affected the slope. I remember that. We're going to only consider the positive and negative. The negative was a flip. Only the absolute value. So if your a value is greater than 1 in absolute value, then you have a vertical stretch. Now, on the absolute value problems, we actually called that narrower. Well, does it make sense if you stretch something up that it would look skinnier? It's the short girl curse, right? When we're short like I am, it makes us look a little wider. If you're tall like Maddie, you're going to look smaller, right? Makes sense. So, b multiplied on the inside, everything on the inside works opposite of what you would think. So multiplying by a number greater than 1 actually shrinks it by a factor of 1 over b. So if b is 2, it would be halving it. And if b is less than 1, it stretches it. So we'll look at all of those. I'm going to come back to that slide, but this slide first. So describe the transformations of the following functions from their base function. Now, luckily, your homework tonight actually gives you the base function. But I want you to even be able to pick out what the base function is, and we'll talk about that as we go. Your homework doesn't list it out like this. You just have to answer the transformation. So if there's only one transformation and it's up 2, your answer is up 2, and that's it. So your homework is probably easier than the depth I'm going to in your notes. This is, yes, I believe it's chapter 5. Maybe 4. No, it's 4. Chapter 4. Yeah, it's chapter 4. Okay, the first thing I want to do is identify the function. So I'm going to glance back at the first slide. I don't think all of you wrote that down. Time out. Right here. First slide. This is like my word bank for base functions. What could it be? It could be any of these. Well, what was the function? 1 minus x cubed. So what do you think the base function is? A cubic. Everyone see how I would pick that? Okay. So that's my word bank essentially. And so this one is a cubic function. So the base function is y equals x cubed. And so you'll see why you want that on what function you're looking at. Now, to answer some of these questions, I may need to rewrite the function. Does anything look out of place for what we're used to seeing with things like absolute value functions and quadratics? Does anything look a little out of place in a different order than we're used to seeing it in?
The x and the 1.
The x and the 1, don't we normally see like x minus 1 or something like that? So if I wanted to rewrite this so that that is what I'm used to seeing, what's the equivalent of 1 minus x if I put the x first? Negative x plus 1. That makes sense. Negative x plus 1. So now I'm going to go through and label how has x cubed been transformed. Well, I know what each piece does to it, so I'm just going to go through and walk through the pieces. First of all, is there a vertical shift? Where do you look for vertical shift? Vertical movement up and down.
It goes up 2.
Up 2. Perfect. How'd you get that? Good. It's on the outside and it's added. Adding on the outside moves up and down. Everyone see how she got that? Horizontal shift. This one's the hardest one because of the B and C thing. Remember, to find a horizontal shift, I need to do the B divided by the C, right? So 1 divided, or C divided by B, sorry. 1 divided by negative 1. What is 1 divided by negative 1? Negative 1. Remember, inside moves opposite of what you would think. You would think negative 1 would go left, but it actually goes right. So right. So again, to get that, I did C over B, which was 1 over negative 1. It's negative, it moves right. If it were positive, it would move left. Any questions about that one?
I thought it was just like the opposite. Like if it says it's plus 1, but it's...
Well, right, so this is minus 1 because you have to take the C into account. And then we see it. So if that one is negative, you move right. If it's positive, you move left. Now, if there's not a number in front of x, then you just go, like that, if this had not been negative, then it'd just be left 1 and you're done. The only time it gets a little tricky is when it's that number. Vertical stretch or shrink? Shrink. Why? And I want you to say by 1/4. So I want you to even tell me where you're getting that number from. Vertical shrink by 1/4, it's less than 1. Is there a reflection anywhere? Is there a negative anywhere? It's a really good question. Is there one on the outside? No. So there's not a reflection of the x-axis. Is there one on the inside with the x? X is negative. So what does that mean I reflect over when x is negative? Look back. Glance back. The y-axis. Any questions about how I did that? Now, your homework tonight does not give you the cues. It doesn't say, what's the vertical stretch? So you'll have to go through and just answer the question. It'll say, what are the transformations? And you'll list them. Now, I did one with almost every kind of transformation. There's some on your homework that only move up 2. And that's all you have to say. It's up 2, down 5. Whatever the answer is, say. Any questions about that one? Now, let's look at this next one. Is it arranged appropriately? Is it what I'm used to seeing with a function? In here, yes, it is. I heard someone say no. What's kind of out of order?
The absolute first, and then...
The absolute value normally comes first, and then the adding and subtracting afterwards. We are used to seeing some multipliers in front, but not adding and subtracting in front. So how could I rewrite this a little bit better? That's equivalent. So change this when we ready. So I'm just going to move that +2 to the back. That way it looks like the other options. It's not a requirement that you do that, but it will make your life easier. Like I said, your homework actually tells you the base function. So a few people got weirded out by that in my second hour. They were like, what's this other function it's giving me? It was telling them the base function. Like, how is it transformed from the base function to the new function? So, what is the base function on this one? Absolute x. What is the vertical shift? Okay. So, what is the horizontal shift on stuff? What are we even going to do to figure that out? C divided by B, right? Which is 2 divided by 2. What is 2 divided by 2? 1. Is that positive or negative? Positive, which means we move left. Left 1. So that's really the hardest part of your homework tonight, is that part right there. It's the horizontal shift. What about the vertical stretch or shrink? Is there a number in front of the absolute value? There's not one. So what does that mean? There's not a stretch or shrink. If it were greater than 1, it would stretch. If it were less than 1, it would shrink. If it equals 1, there's just not a stretch or shrink.
There's a negative in front of it.
There is. What is that? Reflection. Where does it reflect? Oh, yes. Good. Any questions about that one?
So if there's just a negative sign, but there's no number, then there's no stretch or shrink.
Mm-hmm. So you actually notice on it, which we really should answer the horizontal. No, there wasn't one. Is there a horizontal stretch or shrink? Is there a horizontal stretch or shrink on this one? Is there a horizontal stretch or shrink? Where do you look for that?
What could be?
The number in front of the x. Is there a number in front of the x here? 2, right? So, why shrink? Greater than 1. So there's a horizontal shrink, and it's actually by a half, because it works kind of in a reciprocal fashion. Any questions about that one? Okay. Identify the function f, then describe the sequence of transformations from f to g. So first I got to find the base function, then I'm going to describe how the function has been moved from the original. First of all, from this picture, what kind of function is it? The first one on the left. Absolute value. The first thing I would look at is the width of the absolute value function. Normally it has a slope of 1. Has that changed at all? No, it's still got a slope of 1, so my vertical stretch, shrink, none, right? It's a normal width. Has it been shifted up or down? How far? Up to? Does everyone agree?
What are you comparing it to?
The original absolute value function from slide number 1.
Oh, okay.
You know those originals?
Yeah.
So that's what those originals are for.
Okay, so that's what you're saying.
Mm-hmm. So that's why I identify the base function. So I need to see what was the original, and then I'm going, okay, how has it been moved from that original? Has it been moved left, right?
Right.
Right. How many? One. Has it been reflected? It normally opens this way, right? Normal one opens up, it's down. So what? Where is the reflection? Over the E. And then it wants me to write the equation of this graph. I've actually done that last chapter a completely different way. So we can kind of make sure it's meshing with the correct answer with the other options we have. Now, the cool thing about what we just learned for this is does transformations only work for absolute value? Only quadratic? This works for any function. So any function we wanted to graph, we could use this skill, or look at the graph up, we could use this skill to write the equation based on those base functions. So it's kind of cool that it doesn't matter what the function is. So there is not a vertical stretch restraint, but there is a reflection over the x-axis. So I have a negative in front of my absolute value. How do I know it's an absolute value and not a square or a cube or something else? How do I know it's an absolute value?
It's your base function.
The base function is absolute value. It's a b. You know, those dots are going to get us there. How will I get it to move right one? Almost. By subtracting one. Everything on the inside works opposite. It's like topsy-turvy world on the inside of the function. Everything on the inside works backwards. Is what you would think of it. And then how do I get it to move up two? Now, I can't know how you work these problems, right? If you get stuck on something, could you check that equation in the calculator and see if you got that one? And then adjust accordingly? Like if you accidentally put a +1, what would the graph look like instead? It would still look like this, but it'd be good over that way. It would be moved to the left instead of to the right. So you can kind of tell some things. What would make it be up instead of down? What would we have done wrong?
There's no negative.
No negative in front, so that would make it up instead of down. So you could graph it and see and adjust accordingly. Are y'all okay if I skip this one? No. The only difference on this one is it would be what kind of function instead of absolute value? Quadratic, so it would be a square, right? So you have that instead of absolute value to begin with. Otherwise, very similar. Okay, I just want to look at one or two of these. There aren't any of these on your homework. Like I said, on the notes, I'm going into much more depth than your homework actually goes into. Because you have a calculator, for the most part, you just need to identify up, down, left, right, and whatnot. But one of the things I've seen ACT do before is give you an unknown function and ask you what the graph of some transformation would look like. Most people automatically quit because they see this notation and they go, I don't even know what f is. How can I know what f of x minus 2 is? Everyone know what I mean by that? So it paralyzes people because they're listening, I don't know, I can't do that. But it doesn't matter what the function is, transformations work the same no matter what. So what does f of negative x do? Over what? No. Good, over the y-axis. Does everyone agree? Reflection over the y-axis. Did I draw that? I don't know if I can do that. What did I do there to get that? I just took that side, flip it, and take this side and do the same thing. want to do the multipliers first. Order of operations is y. You want to multiply before you add and subtract. So I'm going to multiply by 3, vertically stretch by 3, right? What that does on the graph is it multiplies all the y values by 3. So this y is at 2. What's 2 times 3? 6. So now we'd be way up here at 6. What's 0 times 3? 0. What's 3 times 3? Way up at 9. That's way up here. What's negative 3 times 3? Negative 9. Way down this way. And what's negative 2 times 3? And so that's the graph. Now, to the untrained eye, some people say that looks skinnier. Yeah, but it's really just vertically stretched up, and we kind of talked about why those appear the same. And so that's what the 3 does. What does the minus 2 do? Takes it up and moves it by 2. So every point would be moved right 2. And so I could know what the graph of 3 times f of x minus 2 looks like this, because I can move a couple points around. So the green graph would be what 3 times f of x minus 2 looks like. Any questions about that? This is your homework. We may go do one more example. Do we feel like we've got it, or we want another example? We got it. Got it? Okay, go ahead and get a book out then, because you've got about 10 minutes left in class.